our internet works. So this.
Thank you for this.
Okay.
I think we needed to call a team of experts to solve the problem.
We need at least one person to be a software engineer to work on the development. The network is quite complex, so we will need someone else besides you to handle the network configurations.
And we need a business expert who will analyze the market.
So we need a web expert. We need someone that will make our service available through the internet in a web interface.
We got our team.
Let's start.
Let's start.
And now we go into the details of what we have done. Okay, our project is about open source networking. So first of all, what is open source networking? Open source networking is the usage of open source software to deploy networks. That means not only to make a router using a standard computer with open source software, but also to add the monitoring, the control and security facilities to the network using open source software, only open source. And KTH has already several projects of open source networking in Africa, some like the one from Angola, Mozambique, and Malawi, just to mention some. In our project, we have worked first to backstop the current open source networking projects in Africa, the one in Malawi and Mozambique. We have also worked to make the integration of open source networking tools easier, something that when someone has to deploy a OSN project, he can make it much easier than it was before our work. Also, we have applied this easy approach in the redesign of the network in the DOA, and finally going to the business development of OSN. So, for the backstopping of Malawi and Mozambique projects, both of those OSN projects were at different situations, so we have done different kind of consulting to them. In the case of Malawi, for example, they were not in the implementation phase, so we mainly have answered some questions about learning management system, voice over IP, and IP application process. While in the case of Mozambique, they were ready to implement, or they were starting to implement, but they had a packaging for installation that needed internet connection, and they wouldn't have internet connection at the site. So we have ported this package to an offline package and shipped it to them and gave some instructions, so now they would be ready to install without the internet connectivity. In our efforts to make open source networking easy, one of the things that we have achieved was to write a blueprint. That's a kind of a technical document, a white paper, where we explain open source networking in a component-wise way, where we put, for example, the open source operational system, then basic network service, low-end, high-end net utilities, everything separated in a component-wise way, and with a kind of a clear description of what is open source networking. Because when we started, that was something that took us a long time to understand all the complexity, all the open source tools that are available to deploy those networks. So we have made this document. I mean, this figure, it can be so much clarifying for you now, and we can spend the whole presentation to talk about it. So you can take a look on our blueprint in our website. And now I'm going to call Ralph to talk a little bit about our web visual interface for OSN.
Thanks, Thomas. For the web-based approach, we have used a software called WebMean. It is a web-based interface for system administration for Unix. The system administration capabilities provided by this software are quite broad. It has the ability to manage users, system process, system logs. And it also allows us to create and control the execution of cron jobs and to schedule the commands. This software has many characteristics. It has a very powerful graphical interface. Its installation is very easy, although there is some dependencies for this software. But you have to install first those dependencies, and then you can download and configure it from its website. It's very user-friendly and reliable. Basically, it removes the concept of to configure the big configuration files, and just you follow the web interface to configure and install different tools and services. It supports the concept of modules, so it is open for every person to develop and customize his module and to add into this tool for any purposes. And the most important thing is that it is strongly supported by an active open source community, so this is very important for this. Some tools and services we have developed to this software, some basic network services, DNS, DHCP, firewall, and some low-end services, FTP, proxy, database, mail, and web server. For the NACBus, which is a network monitoring tool, the module present in WebMean is not user-friendly and is working with the previous version. So we have developed a new module for the NACBus in WebMean. Config, which is a connecting tracking tool. Basically, there is no module present for the connection tracking tool in WebMean. So we have modified WebMean to integrate this tool into WebMean. This is the main module page of the WebMean. In the center, there is some general information about the software and the system. On the right side, there are some different sections. In the WebMean section, you can configure basically the WebMean and add modules into it. In the system section, basically you can configure some install packages like system logs, and some other services and systems. In the servers section, you can configure different servers like DNS, DHCP, FTP, and some other servers. In the networking section, basically it provides us some networking facility like to in the installation of firewall and bandwidth monitoring. The sections, others, hardware and cluster, we don't use this section. If someone is interested, can look at the module under these sections. Now I will call Lee to present basically how we developed the NACBus module in WebMean and his practical experience in the Dover redes network.